When should you replace the washer on a racing motor? Let's take a look at this motor. After tightening the screw on the way, you'll notice that when you press the rotor down, it can still move. And when it moves, it even feels a bit springy. But that springy feeling doesn't actually come from the O-ring. It's caused by a magnetic force, which also creates a noticeable amount of play. For the F50 motor, even if you tighten the shaft screw completely, if the O-ring is damaged, the rotor will still move. In this motor, I've actually removed the O-ring inside to simulate what happens when the O-ring breaks or gets destroyed in a crash. Now, if your shaft screw is fully tightened, yet the rotor can still move downward, that means your O-ring is worn out or broken. So now let's put the O-ring back in and tighten the shaft screw on the way. Even when it's fully tightened, the O-ring won't be overly compressed. That's because the F50's shaft design allows you to tighten the screw completely, while keeping the O-ring slightly compressed. This setup is the most crash resistant. When the motor takes impacts from different directions, the O-ring can flex properly, which greatly improves the motor's durability in crashes. Now, when you press the rotor again, you'll find it barely moves. Look closely at the gap between the magnets and the stator. Even with a light push, there's only a tiny bit of movement. You'll need quite a bit of force to make any visible shift. That means the O-ring is in great condition. You can safely use this motor for both racing and training.